Dear students, in the previous classes we have discussed how to compare two population means using pooled t-test, assuming that standard deviations of both the populations are identical, and also non-pooled t-test, assuming that these standard deviations are not identical, equal. In the present session, we will consider a non-parametric alternative to the t-test to compare two populations. The name of the test is the Mann Whitney test. The Mann Whitney test. Now, in order to understand Mann Whitney test, first we consider what is meant by saying that two or more distributions have same shape. What is meant by two or more distributions have same shape? And this assumption is very important when we apply the non-parametric testing procedure. In the non-parametric context, normality is not required. What is required is same shape, symmetric. We will not assume normality. Also, as we have discussed in detail, non-parametric procedures are not based on parameters, but sometimes based on parameters too, that we have discussed. Now, let us first consider what is meant by same shape. We say that two or more distributions have same shape if they are identical, except maybe for the center. Two or more distributions have same shape if they are identical, except probably for the location of their center. For example, two normal distributions having same standard deviation, but different different means have same shape even though the means are different. Similarly, two normal populations with different standard deviations, even though their means the center is same, is different in shape. So this is same shape, identical. This is different shape, even though the center, the mean is same here. So two normal distributions have same shape if and only if they have equal standard deviations. Two normally distributed random variables will have same shape if and only if they have same standard deviations. Now, so far we have developed two procedures for performing hypothesis tests to compare two population means one is the pooled t-test, the other one is non-pooled t-test. And both the procedures require that the samples are raised based on simple random samples, independent samples, normal population or large samples. These are the assumptions. Simple random sample, independent samples, normal population or large samples. Pooled t-test also require that the standard deviations are identical. The standard deviations are identical. And if two distributions are normal, they will be identical if and only if they have same standard deviation. So, pooled t-test is used when two distributions are normal and also same shape, as this is the case. Pooled t-test, two normal distributions and having the same shape. Non-pooled t-test, two distributions, normal but need not be same shape. So this is a normal distribution. This is also a normal distribution. Shapes are different, but we can apply non-pooled t-test. Non-pooled t-test. Another procedure that we are going to discuss to compare two populations based on independent samples, simple random samples, is known as the Mann Whitney test. It's a non-parametric test. It was first introduced by Wilcoxon, further developed by Mann and Whitney. Initially introduced by Wilcoxon, further developed by Mann and Whitney. So, commonly known as Wilcoxon rank sum test or Mann Whitney Wilcoxon test. Wilcoxon rank sum test or Mann Whitney Wilcoxon test or simply Mann Whitney test. And the Mann Whitney test applies when two distributions under considerations have same shape. Let us see these cases. Suppose that we have two distributions, two normal distributions, same shape, pooled t, pooled t, two normal distributions having different shape, non-pooled t. Now consider two distributions. Their distributions are identical, not normal. As you can see, then we use Mann Whitney Wilcoxon Mann Whitney test. Now suppose that one distribution is like this, another is like this. Both the distributions are non-normal, not identical. If the sample size is large, we can apply a non-pooled test or some other procedure will be required. So we are considering Mann Whitney test if the distributions are identical. May or may not be normal. Normality is not required. If normal, we use pooled test or non-pooled test, and parametric procedures, as we have discussed earlier, is more powerful than non-parametric procedures. As an example, Suppose that a shipping firm purchased a new computer system to track its packages. Independent samples of employees with and without experience in this type of system were randomly selected, and time required to learn the new system were used. The numbers are given. That is a new system, time required to learn the new system. Samples are independently taken. The question is, at 5% level, do data provide sufficient information to conclude that mean learning time of employees without experience is greater than the mean time of employees with experience? So, our hypothesis testing procedure can be written as H0 mu1 is equal to mu2. It is mean based or median based, no problem. And H1 mu1 greater than mu2. That is, this is the mean time without experience, and this is the mean time with experience. So, the alternative is mu1 greater than mu2. So, to use the Mann Whitney test, what to say? First, we have to consider whether they are identical in distribution. We can use the stem and leaf procedure. We can also consider the box plot of both the distributions to see they are identical. Suppose that using this, we have the information that the distributions are identical. Now, we have the learning time without experience, with the experience, and we rank them, rank without and rank with, rank with, and without experience 139, 118, 134, the rank is 74, 142, etc. 194, the rank is 46. The idea behind the Mann Whitney test is something like this. If the sum of ranks of employees without experience is too large, then there is evidence that the mean time of employees without experience is greater than or larger than the mean time of employees with experience. In that case, H0 is rejected. And in our case, M is 74. M means the mean time of employees to learn the new computer system without experience is 74. And to decide whether M is equal to 74, to reject H0, we need the table of critical values. As in the first test which we have considered, the test for testing the significance of one mean, Wilcoxon signed rank test, we have a table of critical values to compare the sample values with the critical values. So, critical values for the Mann Whitney test. And in the table, M alpha is given. M alpha. And M alpha is the value of M to the right. M value that was alpha to the right. Area alpha to the right. So naturally, the entries in the table provides what is known as critical values for a right tail test. Right tail tests. Now, to the distribution of m, the distribution of the variable m is symmetric about n1 into n1 plus n2 plus 1 by 2. So it follows that m values that has an area alpha to the right equals n1 into n1 plus n2 plus 1 minus m value that has area to the right. So, m1 minus alpha is equal to n1 into n1 plus n2 plus 1 minus m alpha. Similarly, m1 minus alpha by 2 is equal to n1 plus n2 plus 1 minus m alpha by 2. M alpha by 2 to determine the critical values for left tail tests. So, if you are using the tables, if you are using a software, there is no need for calculating all this. You just give H0 and H1. Computer will give you the critical values, the p values and everything. This is only for the purpose of demonstration. Now, in the example we have considered, in this example, our null hypothesis is H0, mu1 is equal to mu2, H1, mu1 is greater than mu2. We fix alpha at point 0.5% significance level. And our test is a right-tailed test. Right-tailed test. And n1 is equal to 7, n2 is equal to 8, alpha is 5%, critical value is 71. So this is 5%, critical value is 5%. Now, so what we have to do now is, we have to compare this critical value with the value obtained from the sample. This value obtained from the sample was m is equal to 74. So 74 is here. 74 is here. So H0 is rejected. We will conclude that mu1 is greater than mu2. And remember this. Here we compare two means, and as the distribution is symmetric, the test can be performed in terms of two medians also. In the software Minitab, comparison is made between two medians, not means. So you can compare with respect to means or compare with respect to medians. Now let me conclude by considering the procedures. So based on three assumptions: simple random samples, independent samples, same shape, and the first step is formulate hypothesis. Mu1 is equal to mu2, H1, mu1 is not equal to mu2, mu1 is greater than mu2, mu1 is less than mu2. In the second step, decide alpha as 0.05 or some other value. Then third step, determine the ranks. Then in the fifth, compute the value of the test statistics, which is m. And m is the sum of ranks for population 1. Then the critical values are calculated like this. M 1 minus alpha by 2, M alpha by 2, then M 1 minus alpha, M alpha, right tails, left tails, 2 tails, depending on your alternative hypothesis. Decisions are based on whether the value of the ranks M is in the critical region or in the acceptance region. This is the Mann Whitney tests to compare two means when populations need not be normal but identical.